Hello, welcome to the Columbus Metropolitan Club. My name is Steve Marks. I'm Vice Chair of CMC's Board of Directors and President of Hannah News Service. It's great to see everyone turn out today. Today, our forum, One Cool Couple, is sponsored by WCBE 90.5 and presented in partnership with the Ohio Environmental Council and Leadership Columbus. They're represented here by members of the November onboarding Columbus class. Won't you please help me thank and welcome them? And help me welcome WCBE President Dan Michalko to the stage to introduce our guests.
Thanks. WCBE and the Columbus Metropolitan Club share many values, not the least of which is being honest brokers and purveyors of news, information, and entertainment. That's why WCBE and CMC are proud to work together and to be engaged in the community in meaningful ways, especially when it comes to science. As a lifelong science guy and Columbus's alpha geek, I'm thrilled to be here today in the company of what I can say without exaggeration are rock stars of the science world. And actually, yes. And it's one of those amazing things, sitting with them at the table and having a little conversation. They're not really that aware of the spotlight. They're also the chillest couple I have met. So let's get right to the conversation. Please welcome distinguished university professor in the Department of Geography and director of the Bird, Polar, and Climate Research Center at The Ohio State University, Ellen Mosley-Thompson. Distinguished university professor in the School of Earth Sciences and senior research scientist, Bird, Polar, and Climate Research Center at The Ohio State University, Lonnie Thompson. And our host, who is equally up for the title of Alpha Geek, the Chief Executive Officer at the Center of Science and Industry, Frederic Bertley. So Frederic, take it away.
Dan, can everybody hear me okay? Dan, thank you very much, and absolutely I will uphold that Alpha Geek to the best of my ability. First of all, I just want to begin by saying you talked about kind of a rock star group up here. Without question, I'm honored to be here to interview these two individuals. I am not even close to being in the class of their rock stardom. You will hear their story. They are incredible. So I just wanted to distinguish that. But I don't mind hanging on your coattails if that'll help me move along. This is a really kind of Twilight Zone experience for me to be here to host and interview these two folks. Why is that? Well, as many of you know, I came from Philadelphia from a place called the Franklin Institute. The Franklin Institute has the oldest science awards program in the entire world. Started in 1824. To put it in perspective, it is 75 years older than the Nobel Prize. Now, most of us, don't feel bad if you didn't know about it. I didn't know about it before I moved there. You know, most people don't know about it. You know about the Nobel and the Lasker Prize and all these other medals. But it is the oldest comprehensive science awards program in the world. To put it in perspective, every famous scientist you can think of has won the Benjamin Franklin Medal. From Albert Einstein, Stephen Hawking, you name it, they've won it. 119 winners of the Benjamin Franklin Medal have also won the Nobel Prize. So it literally is the Rolls Royce of awards. Why am I telling you all this? Well, I worked at the Franklin Institute, and part of my portfolio was to oversee the awards program. Does anybody know who Marie Curie is? Show of hands. Okay, everybody. Does everybody know who her husband was? Pierre Curie? Okay, so just to tell you what we're dealing with here today. Marie Curie and her husband Pierre Curie won the Benjamin Franklin Medal in 1909. The next couple to win that medal are these two individuals in 2012. So when you say rock stars, you are not even coming close to selling them as strong as they should be. And we all know the Currys, so we know how prodigious and amazing they were. It took 100+ years for this country, for the Benjamin Franklin Medal, to find another couple so suited. What does that have to do with me? Well, I oversaw the awards program, and it's a robust process to pick the winners. You get an idea of the scale. And then when we have the winners, it's my job to call them up and tell them, hey, congratulations, you won a medal. So I'm like, Lonnie Thompson, Ellen Thompson. Now I'm a huge climate, science person, so I knew of their names. But then as you go through the selection process and you see who they pick, you're like, oh my gosh, these are amazing people. So I call them up, and just the most gracious husband and wife ever. And I got to tell you, as a scientist, when you're calling these Nobel-level scientists, some of them can be absolutely apple pie lovely. Some of them can be, of course I wanted to, blah, blah, blah. They were just so wonderful. And so that's A. B. Flew down here, we produced a 5-minute video that captured them. They had to now come to receive the medal. And I'm sorry to put you on the spot here, but we get a call back from Ellen that tells us, and by the way, we won't give you the medal if you don't come. One of the things, we don't give you the medal posthumously, you have to come to the ceremony. It's it is red carpet, black tie, at $1,000 a ticket. It's like the biggest event in Philadelphia, literally. And so I get a call from Ellen, she's like, Lonnie has a little problem. He has a heart situation, and he's on a transplant list. This guy took himself off of the transplant list, because you can't travel more than 2 hours away if you're on a transplant list. Took himself off the transplant list so that he can come with his dear wife and partner to Philadelphia to receive this medal. If that's not cool enough, no pun intended, and we'll talk about your ice course and why you are so cool, he then flies back 3 or 4 days later, on May 1st, gets the heart transplant. That's 2012. So when you talk about rock stars and cool couples, they literally are amazing. And for me, to completely coincidentally move from Philadelphia, my dear wife Heather, transplant here to COSI and to Columbus, when CMC called me up and said, yeah, we're doing this thing, Frederic, I jumped out of my socks to share the table with them because I have this history and I feel like they're family at this point. So it is my honor to be here. With that, I want to start with you guys are a couple. And you're a couple at the cutting edge of research, and not just this esoteric, weird research that, regardless of where you all are in the climate, where the world is on the climate spectrum, it's very important work. How did it all start? Where did you guys meet?
All right, so we met actually as undergraduates at Marshall University, Huntington, West Virginia. Go Thundering Herd. Buckeyes too, but so we actually didn't meet till we were seniors. I was in physics, he was in geology, and both departments were in the same building, but interestingly enough, we didn't really cross paths for the 3.5 years. And then I'll just get it out there. So I was dating a geology major, not this one. And there was the chair's Christmas party, and I don't know if you all know about geologists, but a lot of them like to drink. And so at the end of the evening, there were 2 sober people. Who were they? And he asked if he could take me home. And as they say, the rest was history. And so we, broke up with the one guy, picked up another geologist, and then made our way to Ohio State a year later. He had a year's commitment to the military. And then we came here in 1971, and we were married at that time. So that's the story.
1971. Oh,
That's right, and came to Ohio State that September.
Well, fantastic. So it's nice to see how you were very scientific about the process. You had a man on your arm, you let the folks drink, you studied the crowd, you found the one sober man, you're like, that's my guy. Very good. Okay, so I don't know how much the audience knows about ice cores, but you've built this incredible career on ice cores. We're going to get into the meat and potatoes of climate change and some of your thoughts about that, but just talk about what is an ice core. And what kind of interesting lives did you have? I mean, I know about where you've been for this, but what's an ice core? And then we'll talk about where you've traveled and some interesting things you've experienced.
Well, an ice core is a column of ice drilled from a glacier. And the beauty of our planet is if you go high enough, where it's cold enough, or to high enough latitudes, then every year the precipitation, which comes as snowfall, is preserved. It's archived. And anything in the atmosphere is archived in that sequence. So we look at isotopes as an indicator of temperatures of the past. We look at the layer thicknesses to calculate the precipitation, how that's varied in the past. Very few archives allow you to look at how precipitation has changed on the Earth. But they also record volcanic eruptions. They record variations in the sun and cosmogenic nuclides that get archived in that ice. They record pollen from plants. They record microorganisms, bacteria, viruses. Anything you can think of in the atmosphere is frozen in this sequence. And then our job is to try and read that and interpret it, and then put these individual sites together to get a global picture of what the ice is telling us.
Great. So an ice core basically would be a time capsule, a snapshot of history at whatever period you drilled it from.
Correct.
Right. What's the range from kind of recent ice cores to how far back can we find ice cores to give us a historical perspective?
If we look at the sequence, the oldest continuous sequence we know we have is 800,000 years from East Antarctica. And in that record is a history of our atmosphere, and the bubbles in the ice is CO2, methane, nitrous oxide, all the things we're concerned about today. So you can look at how they varied naturally, long before humans were a factor. So they're wonderful archives.
So that's how we know if the climate is getting colder or warmer, because we can track the levels of stuff then and compare it to today and say, oh wow, things are changing.
Yes, exactly,
Right.
exactly.
Right.
Yeah.
Great, all right. And so we're not drilling ice cores down the street. You're not in New York City hanging out. You're going to some pretty interesting places. Ellen, what are the neatest places you've been to on the planet? And what are some of the treacherous, kind of scary things that I'm sure have happened based on where you've been?
Right. Well, let me just point out that Lonnie and I rarely work together in the field. His work is particularly at the high elevation, the mountaintop glaciers, and my work has been in Antarctica principally and Greenland. So my first field trip was 1982 to South Pole Station, where I was part of a team of 6 people. And our goal was to drill an ice core to about 500 meters, which would give us a record of about 4,000 years. And I was a real neophyte. I had the good fortune of going with an experienced team, and that was the first time. I was a member of a team, but the very next time I went, which was in 1985, I went to a station that doesn't exist now called Seipel Station, named after Paul Seipel, who some of you may remember was the Boy Scout who went to Antarctica with Admiral Byrd. And there I was actually the field team leader, and that was an interesting experience. And again, our mission was to drill about a 300-meter ice core when we were successful doing that. To get to your question, so the very next year I had probably, I've had lots of interesting experiences, but I had one of my most interesting experiences was in 1986. We went to a place in East Antarctica, which was called the Pole of Relative Inaccessibility, Old Plateau Station, and it's the furthest.
Can I just jump in here?
Yeah.
She's going to a place that's called the Pole of Inaccessibility. I mean, That could have been a warning sign.
So what was interesting about that, again, I was the field team leader, but this was actually the first time, I believe, that NSF had a woman as a field team leader in a remote field camp at that distance from, a station. So you wanted to know about an interesting experience. So this is a place where there were the 6 of us. We were there 21 days. We went in, we were dropped off by a C-130 aircraft. You essentially just get put out. The team or the pilots don't like to stay on the ground, so they kind of land and dump you out. And they wait till you get a tent up, and then they say, oh, they're good. They fly off.
Another little hint.
And so then you build your camp, and et cetera, and get to work. Well, what was interesting is we had a resupply scheduled about halfway through the field program, but when the plane came out to resupply us, they couldn't find us. And it was very interesting because, it's a big, flat polar plateau, clear sky, very cold, about -40 all the time. And we could actually look off in the distance and see the aircraft, but they couldn't find us. And it actually ends up, it was a navigational error, and it took them a day to figure it out. This was in the day of no GPS. It was all done with inertial navigation. And so ultimately they had to fly back to McMurdo and reset all their instruments and then come and find us, because they tried to navigate from South Pole, but originally when they put us in, they navigated from McMurdo. So they did find us the next day, but it was, a little bit of nip and tuck there, and it was interesting.
Because to your point, not only don't you have GPS, you don't have cell phones, so you're not in contact with them.
That's
so at that
right.
point in time, you didn't know
Radio.
if they were. So did you know they were trying to come back, or you weren't even sure if and when they were going to come back?
We didn't know when they would come back.
Okay.
We knew they were trying to get to us.
Okay.
Everything was done by the radio, and you did that through South Pole.
Wow, very interesting, impressive. All right, and so, I mean.
Yeah, well, I should.
We're not having husband-wife competition
No.
but share one of your favorite stories.
And I want to point out up front that the reason we don't go on the same expeditions is we raised $1. And her programs would be in the winter, and in the high mountains, they were in the summer. And so our daughter always had a parent at home. And so that was our biggest project, and I would say most successful. But because I work in high mountains, we deal with high mountain issues, and a lot of people think that you go into science or somehow climate science is about money. The first time that we had this idea that we'd like to connect the records coming from Antarctica to Greenland, we took some aerial photographs of a tropical ice cap, the Kelkaya ice cap, to the program manager at the National Science Foundation Polar Programs. And he listened. I told him what I'd like to do, and afterwards he said, Lonnie, I'd like to do that, but I can't, because it's not north of the Arctic Circle or south of the Antarctic Circle. And that was the only thing that they could fund. So I actually was at Byrd Station in 1974 in February, and I got a telex, that's what they had back then, from the program manager, saying, I have funded all of my real science projects, and I have $7,000 left. What could you do on that tropical glacier for $7,000? And I said, we probably could get there. And in 1974, we made our first trip there, and that launched a whole new area of research. As far as the challenges, they are high mountains. So we deal with crevasses, we deal with avalanches. We have drilled the highest ice core recovered on Earth, 7,200 meters, which is 23,500 feet in the Himalayas. So it takes a team, and I would say that there's absolutely nothing that we have done that couldn't have been done without a team of really dedicated people, not only here, but in the 16 different countries we have drilled in. So to me, these are the challenges. But storms are a big issue. And if you're drilling, a drill is on a kind of a derrick structure. It's metal, and we use a wire line. And if you're drilling in the tropics, there are thunderstorms. and you have the world's highest lightning rod that you're drilling with. So you have to be really, lightning can be a big issue for us. Storms, we've had tremendous storms on Los Garon where the whole camp was destroyed and no one could go out for 3 days. No meals were cooked. And the problem with, if you're in a new place, new part of the world, you don't know how strong a storm can be until it's over. And so these are always, they're challenges for working in these extreme environments.
It's just amazing. We're going to get back to women in science. I'm glad you brought that point up. As a couple, how has it been to be a husband and wife researcher? I mean, I don't mean kind of with you, I mean with the rest of the environment, whether it's Ohio State, whether it's the landscape across the globe. How have people received you all as a prodigious, equal power couple? And I say that because, again, 1909 to 2012, it took 100 years for one of the best awards programs in the world to recognize another. It's not common.
Mm-hmm. Well, actually, again, a lot of the work that we've done separately. So I think that over the course of the years, we've been at this almost 40 years, although we have two careers going forward in tandem, we were actually interacting with different communities at different times. So I was much more a part of the polar community. You were much more a part of the tropical climate community. But I mean, the acceptance was fantastic. Maybe I'll add, if I might.
Sure.
For me, one of the best experiences I had as a young professional was in 1986, I was invited to join a National Academy of Sciences study. It was the first committee on global climate change. And it was actually chaired by Ralph Cicerone.
Sure.
Yeah, very
He also
well-known.
won the Benjamin Franklin Medal, by the way.
Yes, he did, and former president of the Academy, et cetera. So I was just very fortunate. There were only 2 women. It was a group of 15, myself and a biologist, a very eminent biologist. And what I found wonderful was the acceptance. Neither of us felt that we were treated any differently. I mean, we were appreciated for our intellectual contributions. Sure. But then, you had similar experiences. And then it's interesting because we began to merge our communities. The tropical community and the polar community, studying global climate change and particularly ice core records, really began to meld. And I think we had a lot to do with bringing those communities together.
Yeah, fantastic. All right, we have a few more questions before we open it up to the crowd. Let's get to the meat and the potatoes here. Climate change. Let's give a little clinic, a 1-minute clinic for the audience as to where we are in 2017 with climate change, A, and B, from a science communication piece, how do we help move this forward?
I would say that certainly climate change, it's real. There's absolutely no doubt about it, and there's absolutely no doubt that humans are playing an important role. All you have to remember is there's 7.5 billion of us on this planet now, and there's never been in the history of our planet that many people. And therefore, everything we do impacts the environment, everything from how we get our energy to how we get our food, and particles that we put in the air from our daily activities. All of this is part of a system, and we're part of that system. And that system is changing. And one of the things we've been very concerned about is the rate at which it's changing. And this is something you see on mountain glaciers. They're not large. They respond very rapidly to climate change. Unlike polar ice sheets, it takes a long time to warm them up and to melt them and see the impacts there. They respond very rapidly, and we've been able to document that through time, through photos of what's happening to the glaciers around the world. And I've often thought that if we had a glacier here in Ohio, like we did 20,000 years ago, and you could see the impacts, then it would be so much more compelling to people in this area. But if you go to Alaska and you talk in Alaska, people, you give a climate change lecture, they're standing room only. because they see it. They have it in their backyard. They've watched the changes. And this is true around the world.
So let me ask you, and a little shout out to Jan Weisenberger. I saw her here earlier. She arranged a meeting with me and you both on Friday, and I was able to walk into there. And by the way, their lab space is the coolest lab space, and no pun intended. You walk into one room, it's the temperature of a fridge, but then you walk into another room where their ice cores are, it's like minus 20. And I'm like, you know, the West Indian blood coursing through my veins, and they're just like, we got this. But we're in there, and you were talking about how you've shown photographic evidence, video, but also a lot of still photos in Congress and different places where you're showing the actual data, but people are still not necessarily believing. How do we change that? I mean, if you guys are the world's expert, which they are, and by the way, the only reason why they haven't won the Nobel Prize, if you're wondering, when I said 119 of the Franklin Medal winners have won, is because they don't give a Nobel Prize for climate change. If they did, they would definitely have one. So just, I want you all to appreciate that. But you guys are leading the field. You got all this data. You've been to the White House. You've been everywhere. What's going on that people are looking at the same data you're looking at, that you're publishing in peer-reviewed journals, so it's facts, they're not in agreement? What's going on?
Well, I think one of the biggest challenges in the communication is that we're scientists. We're not politicians. We don't really address policy. I mean, it's a tightrope for scientists because we have to be faithful to our data. You know, our papers are published in peer-reviewed journals. Most policymakers don't read those. They have staffers who may condense it down to 5 sentences or something of that nature. But we as scientists have to be very careful, you know, that we don't become too much of an advocate. We're not go out and advocate a specific position, because that's not really what our mission is. Our mission is to use the tools that we have to reconstruct the climate of the past, use that as a yardstick against which we can judge what's happening today, and make that evidence available. So there is a communication problem. It's like you go out and you get a PhD and suddenly you're hired as an assistant professor, right? Have you ever had a class in pedagogy? Have you been taught how to teach? No, you aren't taught to teach. And so it's the same thing. We're not taught from the beginning how to work with policymakers. It's something that we have had to learn over the years. And the one thing, and you brought it up, Frederic, one of the things that when we first started, we were collecting ice cores with the idea of reconstructing Earth's climate history. But the more places we visited, the more we realized how rapidly these glaciers are changing. So we started documenting these changes in photographs. We now have photographs that go of specific glaciers that go back over multiple decades. And you show those, and it's amazing that people do get that. And the policymakers, we've had senators come through Bird Polar, and they ask for the photographs. Oh, if I could just put that on the Senate floor. You know, so of course we provide whatever we can. But we really need other people who are more versed at discussing things that are political, to advocate and to allow us to provide the information, but for them to be the primary communicators. But I would say Bird Polar and Climate Research Center, we have education and outreach opportunities. We touch about 12,000 people of all ages a year. Wow. And so we are doing our part, but people have to pretty much come to us. So.
No, I mean, and that's great, and that's why, and here's a plug for our COSI team here, and that's why at COSI we really love to be the bridge between the basic science experts and how do you communicate it out, and that's why science literacy is so important. If you're drafting, if you're the attorney or assistant attorney and you're drafting all these briefs, if you don't understand the science, you're not necessarily going to communicate the right points. So quick, not to put you on the spot, but is there a clock that's ticking for us to save this great planet from a climate change and from an emissions and from all the things you mentioned?
Absolutely. And unfortunately, none of us are wise enough to know exactly how much time we have to make the changes that we will have to make. Mm-hmm. And I think that this is something that we have to be concerned with. We work over in the third pole region, and in Tibet. And there are 46,000 glaciers there. They're Asia's water tower. Big rivers there, the Indus, the Ganges, the
Brahmaputra.
yeah.
We know who runs this.
They all source in these glaciers up in the mountains, and all the glaciers are retreating. And you take the Indus River, in the dry season, 40% of its water comes from melting glaciers. All the glaciers are shrinking. That river flows through China, a nuclear power country, through Pakistan, another nuclear power country, through India, another nuclear power country. All depend on the water in that river, and history, they have not gotten along well. And so we have a new program to try to bring 14 countries in that region together, the scientists. Initially, you have to talk to each other. I mean, communication has to take place. And what you're really doing are building bridges. And to me, I think that we all have to do that because we only have one planet. And if we've learned anything from our international space programs, is how unique this planet is for life as we know it.
Great. We're going to go to questions in about 2 minutes. If you have a question, there is a podium over there. Please go to the podium and start lining up. So you're hearing about climate change and effects in these really far-off, exotic places with really challenging names. But you were here two years ago, I believe, Ellen, on this stage, and you predicted, I think there was a question about, well, what about Ohio? What about the Midwest? And you predicted, what did you predict? I won't spoil it.
Well, they just asked what type of climate changes we might see in the future. I want to point out, I didn't make the prediction. The Intergovernmental Panel on Climate Change made the predictions with very sophisticated models that we all know are not perfect, but they're our best predictive tool. And essentially, one of the things that we can expect in this region is going to be more precipitation. But the critical thing about the precipitation is how it's going to be delivered. And it's anticipated that precipitation is going to come in shorter but more energetic bursts. This is terrible for farmers. You know, farmers like a nice gentle rain that recharges the soil moisture. But when you get these downpours, I mean, it beats the ground, makes it much more difficult to get the crops in, for water to percolate, water runs off, you get soil erosion.
No, I mean,
That's
thank
what
you.
we can probably be looking forward to.
And I brought it up because you just had to pay attention over the last week, the torrential rains we've had and the flooding, et cetera, right? These things are happening all around the planet.
Right. One way to think about it is the climate system just has more energy in it now. You know, why is the climate warming? Because we're absorbing more radiation and releasing less back to space. So it's like a closed box, and it's getting warmer. And when you add energy to a system, it's, you know, that energy drives, you know, all the different motions of the atmosphere and the ocean.
Great. I'd love to hear from our folks in the audience. It's a CMC tradition to take audience questions. Please state your name, ask your question, and in consideration to everyone, please stick to the question rather than elocution or editorializing. So go ahead. First question, ma'am.
Hi, my name's Diana Robinald, and I just want to honor all of you because I just feel so excited that you're doing this. It almost makes me cry. It's so powerful. My question is, I'm very curious. Given the whole, I want to ask your opinion of it, if you will answer, about the whole movement to be a vegan, to reduce meat consumption. And I'm curious if you eat meat and what you think of this whole notion of reducing meat as a contribution that we could all make personally for the environment.
To be clear, this is a question for the panelists.
All right. All right. So, well, I think that is very important. Of course, that's a personal choice. Do I eat meat? Yes. I eat chicken. We don't do the beef. You can look at the energy that it takes to raise, you know, different animals. Beef is very, very expensive from the point of view of the amount of energy that it takes. When you think about it, you know, corn-fed beef is much worse than grass-fed beef because you've got to have water for the corn. I mean, so then I just had my honors students I'm teaching a course this semester. Look at the energy that flows through the food system in the U.S. It's tremendous. You know, from field to table, the energy that's required for transportation, for packaging, et cetera. So there's a question that is often asked, and it's how many, I hate the question, but people will say, well, how many people can the earth support? And there's no answer to that. And the retort has to be, at what level would you like the people on the planet to live? If everybody were a vegetarian, then we could certainly support more people than if everybody ate corn-fed beef every night. Of course, the reality is that we've got something in the middle. But anytime you can eat lower on the food chain, you're definitely decreasing your impact. Because, as Lonnie had mentioned, it's all about energy. And what we have to do is consume less, and the energy that we do produce, we have to make it do more work.
Great. Thank you for that question.
I'm Jane Scott with Columbus Metropolitan Club. Frederic, you and I were having an interesting conversation before the forum started. Dinosaurs are in your future, and thank you very much for doing this today, because you all may not know that the grand opening or the VIP opening for the dinosaur exhibit is tonight. And he and his staff are here, so they're taking some precious time, and we really appreciate that. So dinosaurs and ice cores, what's the connection?
Well, thank you very much for asking that. Little shameless plug. So tonight is the VIP special opening, and November 18th will be open to the public. It's going to be fantastic, but there is a real legitimate connection, and we talked about it in your very chilly ice core lab. Talk about kind of dinosaurs and ice core drilling, and what is the connection?
Well, ice cores don't go back that far in time to where we had dinosaurs on the planet. In fact, when we had dinosaurs on this planet, there was no ice on the planet, and sea level was 120 meters higher than it is today. And so, but in Antarctica, there were dinosaurs, and we have some of the pioneers at Ohio State who have discovered those dinosaur remains. So Antarctica once occupied a much warmer place on the planet. There are coal seams in Antarctica. So it's a matter of the time scale that you're looking at, but the whole system is connected. I mean, it's really amazing. Yeah.
I'm Ken Thompson. I'm an architect, and my question is, do you three believe in a tipping point theory and if so, how far out do you think that is? And then I can just see that little bit of rivalry, that when you come home from one of those cold spots, you're like, I've been from a colder spot than you've been to. Which one of you two have been to the coldest spot?
Well, there definitely are tipping points in the Earth's climate system. There are instabilities. We have evidence of those in the past. As for prediction, that's very, very challenging. I mean, this is the thing. If we knew first of all, if we knew what the next tipping point might be, or when we might experience that, then if we could do that, then we could do planning for it, some type of mitigation or some type of adaptation. But that's only given if anybody believed it. You know, you can put out the information, but often the information is not welcome because it means that we have to move away from our comfort zone. We have to maybe make some hard decisions. And that, you know, that's really a human issue, and we don't really deal with that. That's not, we don't study people. People are far more challenging than the climate system, to be honest. But yes, there are definitely tipping points, and our community is very concerned about those.
And I would say that these tipping points exist in all systems, but particularly with ice. I mean, ice is fine below 32 degrees Fahrenheit. Above 32 degrees Fahrenheit, it's water. It's totally different. And there are all kinds of thresholds in our system, and some of which we know where they are, and some which we do not know. And usually it's always the surprises. We were in central Tibet this summer where last year a glacier collapsed, moved 60 kilometers an hour out 6 miles across the plain, killed 9 Tibetan Sherpas, hundreds of sheep and yaks. And then 2 months later, another one just south collapsed, even bigger. And these are glaciers that have been frozen to their bed. And so understanding what is the mechanism, are they crossing a tipping point? And suddenly they're not stable as they used to be. And it's that behavior of the system that is a big unknown in many of our systems.
Thank you. Next question.
Yeah. Hi, it's Keith Demoff with Green Sun Services and EcoHouse Solar. I have a question about the future of electricity and energy. I believe I've been to your fantastic lab, and I believe I've seen that you maybe use some solar at some of your base camps there, which is really intriguing to me. All around the country, Ohio, solar is taking off. Wasserstrom new headquarters in Whitehall just put up 250 solar panels through some neat financing using property taxes, those kinds of things. So it's happening, but I think we're still maybe 1% of our generation of electricity is done by renewable energy. So, my question is, I'm interested in your own personal experience with solar at your base camps, but also, how optimistic or hopeful are you when it comes to the kind of choices that we might be able to make around energy?
Thank you. Yeah, it's an interesting question. When we drilled Kelkaya ice cap the first time we tried to drill it, we used conventional. And being young and naive, we thought we'd bring a drill from Antarctica, a generator from Antarctica. We'd use a Bell 212 twin-engine helicopter, fly it up there, drill the cores, fly them back down, and job done. But it turns out the helicopters don't operate at those elevations. And they, in the end, at the time I remember the community saying, I really needed to get back in the polar regions because that's where the real science was. But that's when we first thought about solar. This is back in 1980, and panels, the technology was primitive, but we took 2 of them to the ice cap to test it, and it turned out to produce 20 to 30% above manufacturer specs back in 1983. And we designed, that we could do this with a solar powered drill. So the very first solar powered drill was produced at Ohio State. We tested it on a parking garage. We put the panels up. We brought in blocks of ice, and we drilled through those blocks of ice, and it seemed like it would work. And so,
did they think you were college students pulling a prank at this point, drilling in the parking lot?
Well, even the National Science Foundation didn't think this was a good idea in 1983, and we had failed in our first attempt with a helicopter, and here we're proposing to do it with solar, and had Willie Dansgaard, who was one of the reviewers and a great friend and pioneer in our field, review stood. He said that the Kelkaya ice cap was too high for human beings, and the technology did not exist to drill it. But there was a program manager who said, Willie might be right, but we won't know unless we try. And we took that drill down, and we drilled not 1, but 2 cores to bedrock. 1 set of samples we sent to Willie Dansgaard's lab in Denmark, and from that time on, he was our greatest supporter of how important these archives were. But the solar, it has come so far. We now have panels that they're flexible. You just roll them out, and they produce 5 times the power for half the price. And so we have made tremendous, and this is why I'm optimistic. As human beings, we're innovative. We can come up with ideas, ways to produce energy without destroying the environment in which we live. And to get back to your earlier question, I used to go to the U.S. Senate quite a lot, and there are good people there, this is for sure. But the real change is coming here, from the bottom up. I was out in Iowa. The state of Iowa now gets 30% of its electricity from wind. The change is taking place. And so part of this is human behavior. And if you go back to Benjamin Franklin, If you go back to that time, in 1741, he invented this stove made out of metal that would burn wood more efficiently. But there was a tremendous pushback by the industry at that time because there were stone cutters who cut stones for fireplaces. There were wood cutters who, cut the forest. So there were lots of jobs at risk. But the stove was still a great idea, and it caught on. And we, as human nature, we resist change, especially if there's money to be made. But it doesn't stop the change. So I'm very optimistic that we will find a way to balance our energy needs on this planet.
Yeah. So we have time for three people. 3 quick questions, please.
Okay.
That is.
I'm Samuel Dane from Columbus Alternative High School, and as someone who's considering going into polar research, I was just wondering whether or not you had an interest in the outdoorsy kind of aspect of your job before you started doing it.
I think it's very important to have an interest in the outdoors. I was an Eagle Scout, and I really, and a lot of the things we learn in scouting, I've used year after year and still use when I go into the field. So yeah, you have to have an interest in outdoors, I think.
Well, I would just ditto that. I think our second date was a camping trip.
That's right.
I want to thank you, young man, for being a high school student here and asking that question. So
Yes.
terrific.
Yeah.
Hi, Skip Cornett, 1974 Marshall University graduate, native West Virginian. We know that coal is in serious decline in our state of West Virginia, but what I want to know is what's happening. What's the global trend? Are we burning less coal? Is it moving away? Is it going to be replaced? And if that happens, what's it going to look like? Thank you.
Well, the projections from the International Energy Association is that the outlook by 2040 for coal is down. Nuclear is going to be flat, but coal is definitely going to be down, maybe 5%. And even countries that are very coal dependent, China's an example, are cutting, they're going to be cutting coal. And in terms of the renewables, the big push is going to be wind at the most, and then secondarily solar. That's 2040, those are the projections.
Last one. Hi, my name is Laura Ellswick. You mentioned that your oldest sample dates back to about 800,000 years. Do you think that's the limit, or are you trying to find older samples?
That's a fascinating question. And one we're actually tackling with our latest field program was in Western China in 2015, and we drilled a core 310 meters, and we just got our first dates back, and the bottom of this core is well over 653,000 years, which was the limit of that dating technique, chlorine-36, that we were using. I do not believe we have found the oldest ice that's preserved on the planet. And there are a number of different groups around the world who are actually looking for that right now. Yeah.
Great. Well, that concludes all the questions. I want to turn it over to our prodigious Steve Marks for concluding remarks. But thank you both.
Great. Thank you. I hope you enjoyed today's forum. I know I certainly did. So. We encourage you to continue the conversation with cookies and coffee in the back. You can view and share today's forum and all of our forums on CTV, Columbus Television, on WOSU and PBS affiliates statewide through the Ohio channel, and anytime on CMC's website via YouTube. Let's thank our sponsors, WCBE, and our partners, Leadership Columbus Onboarding, and the Ohio Environmental Council. And of course, our speakers, Ellen Mosley-Thompson, Lonnie Thompson, and Frederic Bertley. And thanks to all of you for being here. We look forward to seeing you next week at CMC.